Okay, this is the third review video that I'm doing here from questions I got from email. The last thing somebody had asked about was harmonic motion. So that I don't have to write the problem fully out on the board, I'm going to do page 662, number 23. Okay. A boat leaves port and follows a course of north 77 degrees east. So I know the first thing I'm always going to do is draw a picture. North 77 degrees east means I'm going this way, and this is the 77 degree angle to the east. At 9 knots for 3 hours and 20 minutes. So let's see, 9 knots is 9 miles per hour. So in 3 hours, I would go 27 miles. And it's 3 hours and 20 minutes. 20 minutes is a third of an hour. A third of 9 is 3. So 27 plus 3, I go 30 miles. So I'll just stretch this out and say that's 30 miles. Then the boat changes to a new course of south 28 degrees east. So now we change colors. And again, starting here, I just draw another little coordinate axis. And my new bearing is south 28 degrees east, which means I'm going to go this way. This angle, the angle east, is 28 degrees. At 12 knots for 5 hours, 12 miles per hour for 5 hours, that's 60 miles. Just looking at this picture, one question that can arise is, well, should I be stopping in the first quadrant or going to the fourth? And even if you draw your picture wrong, the math algebra trig at the end will tell you which quadrant you should be in, even if you end up in the wrong quadrant, as long as you understand your solution. But if you think about it, this is 30 miles, I'm going 60 miles this way, and this angle is much steeper, 28 degrees. So it seems logical, in my head at least, that I should end up down here. Even if I just double the length of that, I should end up somewhere down here. We might end up being wrong, but we'll catch that at the end. These pictures are just a guide. Okay, how far is the boat from port? Well, that's the distance from the boat to the port. So answering that first. How do I do it? Well, let's see. I don't have a right triangle. I have this side and this side. But since it's not a right triangle, I can't use like Pythagorean theorem. But I have this part of the angle. If I can get this angle right here, then I can use the law of cosines because I'll have this angle and those two sides. And now here is where we use geometry, and I'll try to color coordinate this. If I draw that vertical in black, my original black, then I'm going to draw this vertical again in blue. I have this green cutting through them. I know that this angle is 77 degrees. That's a transversal cutting between two parallel lines, which means that's 77 degrees, which means this is 77 degrees. So now I know that angle in the triangle. It's 77 plus 28. 8 and 7 is 15. Carry the 1, that's 100. That's a 105 degree angle. Now I can apply the law of cosines and get C. So let's see. C squared is equal to A squared plus B squared minus 2B, or AB, I'm going to keep using the wrong letters, cosine C. Now hit all the buttons in your calculator. Let's see, 30 squared plus 60 squared minus 60 times 60 cosine 105. 5431.74. So C squared equals 5431.7485. You can just leave this in your calculator. I'm just kind of sketching it out so when you're working with your calculator you can see what you should get. Because I care about C, so I'm just going to square root it and get 73.7. So C should be 73.7. And now just ask yourself, is that logical? Well, let's see. I went 30 miles this way, 60 miles this way. I've traveled 90 miles. But some of it was vertical in both directions, so it didn't go perfectly straight. So my distance from port should definitely be less than 90 miles. Because to be 90 miles, I would have had to go 90 miles due east. But I went a little bit north and south. So yeah, that seems logical. Now, suppose that the boat becomes disabled. How long will it take a rescue boat to arrive at if the rescue boat leaves from port and travels 18 knots? I'm not even going to bother to do the math on that one, because clearly if it's going 18 miles per hour, you would just do, since it's going from the port to the boat, 73.7 divided by 18. Throw it into your calculator, get an answer, and you'll be good to go. What bearing should the rescue boat follow? So now, and we've established before, knowing where you're starting and where you're going is important. The rescue boat is going to start here and go here. Based on my picture, it's going to go south and east. If this boat was going back to port because it wasn't disabled, then I would have to go north and west. Direction matters. I'm going from rescue boat to the boat that needs help. So I'm going to go south and east. Now that dictates the angle I care about is this angle right here. That's south, that's east. So there's the angle I want to find. Now it's entirely up to each individual problem, the geometry and the trigonometry you know to solve it. In this case, I know I essentially have this and this. I know that's 77 degrees. I want to find this. If I can get that angle right here in the triangle, I can add these up, subtract from 180, and get that angle. But on my triangle, well, I know this angle. It was 105 degrees. I know this side. I want this angle. I have this side. Law of sines. So, sine of 105 degrees over 73.7 equals sine of B, I don't know, I'm just making up a letter, this angle, over this side, 60. So I get 60 sine 105 equals 73.7 sine B. So divide the 73.7 over, and I know all of you can do this, but 60 times sine 105 divided by 73.7, 0.7863. 0.7863 equals sine B. And then do the sine inverse. Second sine inverse, second answer, enter. 51.8 degrees. But now keep in mind, we're still not done. That's the angle in the triangle. My answer is this angle here, but now add those two together. 51.8 plus 77 equals 128.8, and then subtract from 180, and you get 51.2. And now this is the angle I want, south, 51.2 degrees, east. And again, I stress, like I did with all the other examples of this I've done, there is no hard and fast set rule to solve them. If you end up with a right triangle, you turn at a right angle, then yeah, you can use SOHCAHTOA, things like that, Pythagorean theorem. When we have this more realistic problem where I'm turning at random angles, it's just random geometry. Draw the coordinate axis to start, draw the coordinate axis at the corner when you make a turn, and then think about geometry. The blue and the black are parallel this way, the blue and the black are parallel this way. I have transversals cutting through them. Use tricks like that. And again, a lot of times when these angles aren't right angles, you'll end up using the law of cosines. But we know from solving triangles, once you've used the law of cosines one time, Then the rest of the solving inside the triangle can be done with law of sines. And then it's just manipulating to get the particular angle you want to solve the problem. We will actually look at these a different way in the stuff you're doing now at the end of chapter 7, using vectors, which makes this work a little bit better. But for right now, we're going to use this.